Hello, I am Miss Braden, and I'm doing a lesson, a video version of the lesson that I did in my Math 1 class on rotations using tracing paper. So we've been learning about the three different types of rigid transformations, and now we're on rotations. In class, I gave you this sheet that you can see right here, and we did a couple demonstrations with several of these rotations using tracing paper. You might be able to to figure these things out, like because you're a very visual, spatial, intuitive thinker. But you should always, I still want you to understand how to use this tracing paper. Still want you to understand how to use this. It's very valuable for checking your work if you're using a rule, or if you think that you understand how to do something intuitively. So, and with that said, this gives you an approximation. It shows you approximately where on the coordinate system the pre-image is going to land in order to create the image. But it doesn't give you precise values for these coordinates, where they get mapped. Regardless, we are going to do our best, and we are going to list out these coordinates, the coordinates of the points in the pre-image here, and then we're going to show where those go, how those get mapped to the points in the image. So, getting ahead of myself, first thing I want us to do actually is just list those three important pieces of information you need to do a rotation. You need the center of rotation, which I call the COR. You need the angle of rotation, AOR, and you need the direction. Clockwise, counterclockwise, the other way would be this way. Go. Clockwise or counterclockwise. So right off the bat, we can see actually that for number 1 and number 2 and number 6, there is no direction. We have the angle, we have the center of rotation, but we do not have a direction. And why is that for these three? Well, what do they have in common? They're all rotations of 180 degrees. So if you have something that you're rotating by 180 degrees, like this pen is getting rotated around the center, about the center of the pen. If I go counterclockwise, about this center, 180 degrees, that's a half turn, and it ends up facing me. I do a half turn clockwise, and it still ends up facing me. So it doesn't matter which way for a 180 degree turn. Let's just quickly make a note here. COR, we know the center of rotation is 0, 0, the origin. And the AOR is 180. Cool. The other thing I want to make a little note of up here in the margins is when we're doing multiples of 90 degrees, multiples of 90 degrees, that of got a little squished. We can talk about this in terms of quarter turns. So quarter turns, just like when you're looking at a clock, you have a quarter past 2, half past 8. So for where I'm going with this is we can describe a 90 degree turn as a 1/4 turn. And a 180 is like 2/4 turns, which is 1/2 turn. And a 270 degrees is a 3/4 turn. And a 360 is a 1 full turn. Okay. 1/2, 1 full, 3/4, 1/4. In fractions, that's like this: 1/4, 1/2, 3/4, 1. Okay, so that clock, you got that clock thing going. There's 3/4, 3/2, 1/4 till, which is the same as a 3/4. 1, 2, 3. And that's 270 degrees. So that's the one you probably don't know, that are not that familiar with, is 270 degrees is a 3/4 of a turn. So it's easy when we're dealing with multiples of 90 degrees. Easier when we're dealing with multiples of 90 degrees. So anyways, let's move on. Let's see. We're dealing with, in this case, a full turn, or a half turn, I should say. This is a half turn, right? Let's first list the coordinates of these points, because I'm going to end up listing the image points. So I'm going to list, at this point, I'm going to list the points in the pre-image. So each of these points that are here, because this is the pre-image. So P is 1, 4. It's going to get mapped to P prime something something. K is 3, 0 is going to get mapped to K prime something something. And N, -1, -2 is getting mapped to N prime with some coordinates that we don't know yet. F is -4, 2, getting mapped to F prime. Okay, and we're going to find out what these coordinates are in just a minute. So at this point, I'm going to use this information I have here to begin doing the transformation. First thing I want you to do is mark that center of rotation. In this case, it's the origin, 0, 0. Let me also show that these are increments of 1, just by labeling this outermost tick mark on each part of the lines. The last thing before we put the tracing paper over and start tracing is to mark a reference segment on one of the grid lines starting at that center, because this line, this reference segment, is going to act like our little clock hand. So this segment is going to get turned, and it's going to tell us whether we've gone 1/4, 1/2, or 3/4. So this little segment is going to be like our clock hand. Reference, that's why I call it a reference. So now we will trace. I put the tracing paper on top here. I'm going to trace the shape. Some people like to just trace the points, but I'm going to trace the whole shape. I like to see the outline at the very end. It really helps me know that I did this correctly if it looks like the original shape. But now you need to trace the center of rotation right there and the reference line. Okay. And I didn't say so, but I also labeled these points here, the vertices, I labeled them with primes, because when I end up transforming this somehow, it's going to end up being the image. So I might as well just label that with prime symbols right now. Because, here we go, we're going to transform this thing. So take your center of rotation and put your pencil right on top of that guy, because that's going to help you swivel this around with that, swivel it from this point. So we're going to go 180 degrees, and we don't care which direction, remember, because it's 180. So the way this works is we're going to watch this clock hand, how it moves with respect to the original 12 o'clock hand. How is it moving with respect to that original clock hand on the bottom? It looks like that might be about 45 degrees. So if I land right here, that's 90 degrees. This angle right here is 90 degrees. But I need to keep going. I need 180 degrees. That would be right here, where this clock hand lines up again with the original line that I drew the this reference line on. But it's pointing the opposite way. So if you were to look at this in terms of like the actual angle, you would see that this angle right here, from the underside to the top side clock hand reference line, is 180 degrees. Okay, and that tells me that I'm done. I don't need to keep rotating. This is the part that confuses people. They don't know when to stop. They're like, okay, I have the reference point, I have the traced shape, but how do I know when to stop? How do I know when to stop? That's what the reference line is for. And when you're doing increments of 90, you know that that reference hand is always going to line up with one of the with a grid line. In this case, one of the axes, the X or Y axis, because the center is the origin. If you're dealing with a different point, like this point up here, it's not going to be an axis, but it's still going to be a grid line. Okay. All right, now this is the part where we figure out what these points are. And you can either trace the shape, you can use various methods of finding out, of tracing this final shape onto the paper underneath. I like to approximate these points, where these points look to have fallen. This one right here looks like 1, 2. This one right here looks like 4, -1. This one appears to be -1, -4. And this one looks like -3, 0. Okay. And again, there's other ways of doing this. You could have like outlined the lines underneath and then pressed the graphite down to make an outline. You could have poked holes through this to like create those points, right? Kind of like that. All right, I see that point goes right there, and you lift it up and the point is kind of marked there for you. I did the method where you kind of approximate the coordinates, and then you write down the coordinates after you take away the tracing paper. So n prime, I got 1, 2. F prime, I got 4, -2. K prime, I got -3, 0. P prime, I got -1, -4. Okay, quickly plot those guys. 0, 1, 2. Whoa, that doesn't look right. Oh, that's because that was -1, 2. And lastly, 4, -2. 3, -2. I'm really struggling with this right now. All right. And then the labels. This is F prime. This is N prime. This is P prime. This is K prime. All right. Trace these, connect these points up. Connect those points. And I'm done. There we go. Beautiful. Wonderful. Last thing, that's it? Well, that's it. You can write the coordinate rule if you want, but that's where I'm going to stop for today. So thanks for watching.